Hi, my name is Ben Neely. I am from NIST and the iPRG, and today I'm providing a very light intro into the topic of cloud computing with a focus on proteomics. First, I'd like to give a quick shout out to Devin Drew, who helped me a lot with this way back in 2020. And also to mention that most of this was in a little paper I wrote in 2021 that you can see as well. So let's get going. Right, so the cloud. Yeah, so the cloud is actively used in a lot of fields that we think of, things like particle physics, material science. Also, people doing a lot of nucleic acid sequencing. They're not sitting around analyzing that on their local workstations. And honestly, pretty much anyone doing anything related to e-commerce. Really, when I look around, it seems like it's pretty popular everywhere, except then there's us, right? It seems like every proteomics lab has these like on-site computers, right? I have it too. I have like computers that glow and they're fast. It's awesome. But somehow or another, it seems like we convince ourselves that we needed this, and I'm not sure that's exactly true. One of the reasons, again, I wrote this paper was my neighbor who is in tech laughs at me every time I talk about using a workstation to do these big analysis. He's like, but you're not doing blah, 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 blah. And I'm like, I'm not. And I was like, why am I not? But the real reason for this kind of paper in this just kind of a reevaluation was a situation back in 2020. So let's say you have this big data set, not even a big data set. Let's say you've got 30 files that you need analyzing. But the problem is that you're a new trainee with some new laptop. And this is what was happening in 2020. And that trainee, the laptop was horrible. I mean, actually, maybe it was fast by those standards, but it was one step above like a Chromebook. And then on top of that, this was just a summer student who was offsite. Like, I never met them. This is a thing that happens, I think, more than we give credit. But it can also happen where you have remote colleagues in another country. Maybe this is part of an outreach program you'd like to do. Let's teach people in Costa Rica how to do mass spec-based proteomics. You can't really do that when you're resource limited. Also, like today in California, there could be brownouts, but maybe you live somewhere where like the power is not super stable. You don't want to start some long job. Or maybe you're like me, there's hurricanes. Again, you can be limited by your actual environment. So your computational environment and then like your actual environment. And so this is when you get this idea of the cloud comes to the rescue, which is also known as just someone else's computer. And none of this is new, right? Back in 1950, it was like, hey, look, you can have 150 extra engineers. But these are not new ideas. So someone else's computer, which could be Amazon, it could actually be your labs cluster, it could be your institution, whatever. But now you have these benefits, right? Like that new person doesn't need to know how to install the software. They don't know, you need to know anything. You can just have like this proteomics kind of cloud image for them. They also don't have to worry about CPU and RAM resources, right? They could be running a Chromebook and they can be running faster than you. They also, don't need to worry about if their laptop turns off, if it breaks, explodes, is stolen, a hurricane comes, wipes them out. You start the job, you walk away, boom, it's doing its thing. You leave it there, you can come back later. I can come back, anyone can come back and check it. So again, kind of some obvious benefits, but just to reiterate. This is going to be gone over with a lot of detail in the coming workshops, and I won't try to talk about, but just generally, like what are we talking about? So you've got your local workstation. The first step is you're accessing this cloud-hosted environment. Again, this can be in Google, Azure, Amazon, whatever, even little local instances. You can even make your own. But once you're there, you can allocate more resources to this environment than you have available locally. And there's a lot of choices there. And those choices probably cost money, but who knows? You also, at that point, you can either do things called workflows, which I think a lot of the workshops are going to be dealing with, or honestly, you could just fire it up and run a program like you normally would, right? Like maybe I don't know how to run a workflow because I haven't taken this workshop. Maybe I just want like kind of like a remote PC that has all my favorite things already set up. Now, something that's really cool is that once you're kind of in the cloud, you can dump your data from your mass spec directly there. Right? We already do this eventually for publication, but what if you started off it? What if you created, sometimes this is called like a data lake. What if you went ahead and you did that, and then it was already there? And so again, now I don't worry about a hurricane or something wiping out my local data. It's already there. I can just kind of mount it onto different images. Super fun. Also, you can retrieve data from public repositories. And again, in this case, like let's take my person in Costa Rica or India or wherever, they don't need to worry about their internet connection to these sources, right? Because they're accessing something that's in the cloud, and then it's the connection from the cloud to Massive or Pride or wherever. So it makes for a lot of fun benefits. And again, today or over these coming workshops, you're going to be learning about these specific Transprotein Pipeline Galaxy Nextflow, and I won't say anything about those. Leave that up to them. A couple more things though to mention is there's a lot of different ways to use the cloud, and I think that's the point, right? You don't need to be a bioinformatic wizard to use distributed images containers workflows. It's much easier than you think, and I think it's much easier to do. You should just try it, see how it goes. Also, you don't need to have a giant need to take advantage of this, right? Like you don't need 1,000 files. It could be 30. Honestly, just play around with it. And also something that I'm not super familiar with, but I think will come out in some of these talks, is that the solutions can be hybrid, right? So in other words, you can run parts of things locally and parts in the cloud. Something, again, that my neighbor likes to joke about is this idea of functions as a service, right? So it's not even that I have an image. It would just be like, oh, MS Convert is really slow at this step. I'm going to only do that computational step in the cloud, and I'm just going to offload that. And I think you see this again, particle physicists, things like that. They do this. Also, the cost can be lower, but you're going to see this again with the real professionals in these talks later, is that you need to manage those allocations. Like they cost money, so turn them off. Turn them off when you're not using them. And I really do think that using these cloud resources is a great normalizer between kind of the haves and have-nots, right? Like you don't have to have a room full of flashy computers. You can just have maybe some free credits on Amazon. And I think that's really empowering and not to be, I think it's something that we all need to think about. And again, my main 3 points in general about the cloud, as I said, it's accessible. You can access and share from anywhere with the internet. That's sharing your data, but it's also sharing kind of that workspace or sharing your workflows, right? Scalability, again, you can instantly scale really big or not, right? And I think kind of with the accessibility is this reproducibility or reportability idea. And that's that I can share exactly what I was doing. And this doesn't mean like I'm sharing my code. It means like I shared the whole environment, right? So 5 years from now, you don't have to know, well, what version of Python did he use? What version of Max Quant was he using? Whatever, like it's just there. Like my area is just there. So everything that went along with that paper is there. And that's really cool because you can instantly benchmark using the old analysis and then start making those changes. And I think, again, that's really powerful. And that's pretty much everything. Again, you're going to have a much more detailed discussion of these tools and some examples, and you're going to go into all these things that I skipped over. But regardless, I think this is something to be considered and something to see if it works in your current situation. And if it does, go to town. Good luck. And thank you all for coming, and thank you to the other speakers for taking time to give these talks. Thanks.